Hi everyone! You're on the PVS-Studio channel. Today, we'll cover a major topic of application security. In particular, I'll tell you about various approaches that an attacker can use to achieve some malicious goals. It can be an access to sensitive data or, in some cases, a crash of the entire software system. At the same time, you'll find out what Taint-analysis is and how to protect against such attacks using it. So let's take a look at one of the attacks using a synthetic example. Let's take perhaps the most famous one, namely SQL Injection. Suppose there is a simple method where some operations deal with user data from a database. Let's figure out what is happening here. First, the application receives a string containing a user login. Its value is taken from a request sent by someone. Next, the SQL command object is created. Pay attention to the request string here. With such a command, the application loads all user data with the login written to the user login variable. The command executes and the received data gets processed. It all seems simple and clear. What's the potential vulnerability? Remember I noted that this request with the login is taken from an unknown source? Well, I said that for a reason. This means that data in this request can be absolutely anything. The essence of many attacks is that application gets value from the unknown sources. An attacker can send this request that will let a person to achieve different mean goals. It all looks simple in our example. Let's say the attacker passes this line to the user login request parameter. It will be saved to a variable. The request is based on the following template. You've probably guessed that the final request won't do any good. Just in case, I'll be clear that such a request will remove all users from the database except for Robert. Well, there may not be any Robert at all, so all users may be deleted, or well, one lucky user will remain. The attack I showed is just one of the possible options. Apart from SQL injections, there are still a bunch of other ones: path traversal, XSS, insecure deserialization, and others. Follow the link in the description to find out more about them. In the example shown, the error is very noticeable. The data is not checked, but it's immediately thrown into the request. So what can we do with it? Basically, the type of security depends on the specific type of attack. For example, there are special parameterized requests to protect against SQL injections. In case of this attack, this approach helps really well. As for other attacks, it's usually more complicated. Each case requires specific validation. And yes, you can easily spot a bug in a simple example. Alas, developers don't write code like this in real applications. Most likely, the processes of getting data from request parameters and SQL forming are in different places, so you can never tell where data has already been checked. For example, we have a super large system that handles a variety of user requests. One of possible requests may be an operation with files. After we untwist the code, it turns out that the request is aimed to delete a file. After that, we have some other operations, and two of them interest us most of all. The first forms a path to a deleted file. The second calls the delete method located in another class. Note that the user can delete only one file from the personal directory. And here comes the moment when the file is deleted and everyone is happy. And the attacker is the happiest. With a path traversal attack, the intruder can now delete any file in the system in addition to user's directory. Well, system access permissions still have to be taken into account. If you are interested in learning more about this attack and how to deal with it, follow the link in the description. Here's the main problem that I wanted to demonstrate to you with this example. Every single code fragment can look quite normal and safe, but if we consider several fragments at once, they may happen to be vulnerable to attacks. The reason is that a developer may think that in each piece of code, data has already been checked or will be checked later. When there is a lot of code, it's hard to carefully review it. Here's where Taint-analysis comes to help. Taint-analysis is a technology that allows you to monitor possible flows of unchecked external data. Take a look at an example. This code is also vulnerable to path traversal because an attacker will be able to access files not only inside the specified user directory, but anywhere. //sequences or passing absolute path instead of relative ones will help on this. The trouble is that data is not checked again and is passed where you don't want it to. Taint-analysis allows you to automatically find such problems. To demonstrate the capabilities of taint-analysis, I use the PVS-Studio static analyzer, which, by the way, searches for a huge variety of errors in addition to the ones related to taint analysis. So the analyzer warns that this code is vulnerable to path traversal. By the way, potential vulnerabilities that we discuss in this video relate to a fairly simple idea. There's the concept of potentially corrupted data or tainted data. There's the data that could potentially be sent by an attacker and could contain all sorts of dangerous things. There's some place where the application gets the data. In taint analysis, it's called a source of infection. For example, the source of potentially tainted data is where the request parameter is read. Data is somehow written to new variables used as function arguments, and so on, while the application is running. Apparently, the infection is passed together with data. For example, if we copy potentially infected string, the resulting copy will be potentially infected. Finally, potentially infected data reaches some point of no return, the so-called taint sink. So infected data can get into the sink. This means there is potentially vulnerability that an intruder can take advantage of. As you understand, every attack has its own sink. For example, for SQL Injections, it's where infected data gets into the command object. For a path traversal, a sink is usually the process of passing potentially infected data to a method that performs file operations. In this fragment, the source of infection is the location of request form. Then potentially infected data is written to the relative path variable. Later, absolute path will become tainted, as the infected string is a part of the path combined call. Eventually, the infection hits the sendFileContent method, where it gets to the sing, call of the readAllText method. This method can read a file with, let's say, secret administrator data. In the end, an attacker will receive this data. Perhaps you have a question now. Okay, what do I have to do now? In this case, you need to protect yourself against path traversal somehow. The easiest option is to check string for //sequences and make sure the user has not passed the absolute path. In this fragment, the resulting path is checked accordingly, although the specific check is only relevant for Windows. During taint analysis, PVS-Studio does its best to take such checks into account. Therefore, the tool will not give a warning when really checked data gets into the sink. Once the path validation is added, the analyzer stops generating the warning that we showed previously. So taint analysis allows you to find potential vulnerabilities in your application. This dramatically improves its reliability. If you are interested in this topic, you can also read a small article. Find the link in the description. As for PVS-Studio, it's been a while since taint analysis was added, but this mechanism was constantly evolving and is now very capable. If you'd like to see how it works yourself, you can also find the link in the description to download the analyzer for free. Thanks a lot for watching! Don't forget to like the video and subscribe because we're about to release many exciting videos. Bye!